Okay guys, welcome back to Math with Mr. Miller. I'm going to go through some of the ambiguous case today when working with law of sines. Now the ambiguous case only comes up in specific situations where we have one angle that is not included between two given sides. So all of these triangles here, I've got an angle here at x, and an angle here at r. Notice that it's not included between the two sides that I have. And what happens here is we end up with a couple of different situations. We could end up with potentially having no functional triangles. We could have one functional triangle, or we could have two potential triangles. And it all kind of depends on the side lengths and things that you have. Okay. The key thing here is there's the potential of getting more than one possible triangle. And that happens in these situations because we don't know if our triangle, let's say I'm looking at this first triangle up on the top left corner. We don't know if this triangle, if the side of 38 here, if it's going to end up where I have it drawn in the picture, or if you imagine there being kind of like a hinge at point B, it could actually swing in and land somewhere over here. Okay, so there's two potential triangles that could be formed because we don't know how long A to C actually is. So since there can be two potential triangles formed, we have to account for both of them when we solve. The other possible issue here is it could potentially not even actually form a triangle if sides like side AB are too long. So what we need to do is we're going to go ahead and just start with our law of sines, focusing just on the triangle that we have here. So I'm going to go ahead, I'm going to take my law of sines, I'm going to rewrite it up top. So I've got sine of A over side A equal to sine of B over side B. And I'm going to go ahead and I'm going to just plug those things in. So I'm going to start with sine of 27, and I'm going to solve for my missing angle at angle C to start. So sine of 27 over 38 equal to sine of C over 112. And I'm going to go ahead and solve. So I'm going to multiply my 112 on both sides. It's going to give me sine of C equal to 112 sine of 27 over 38. And I can take my inverse sine of both sides to get my angle C. And what actually will happen on this one, when we go and actually type that into the calculator, C is going to pop up with a domain error. Okay? And that happens when the triangle actually cannot be formed. So in a case like this, we would just say 0 triangles can be formed. All right, so in this case, this particular triangle here doesn't actually work. It doesn't actually exist. That might not be the case, though, every time. So I'm going to go ahead and erase the work I have here. So if you needed it, I would go ahead and rewind a little bit and pause. And we're actually going to go ahead and do this now for the triangle on the right. So I'm going to go ahead and give this another shot. This time I'm going to look for my angle Z. So I'm going to still set up my sine of 24 over 7 equals sine of Z over 15. Okay, I can't find that angle Y yet because I actually don't know what X to Z is, so I wouldn't even be able to plug anything in to my formula to solve for Y. I'm going to go ahead and simplify. I'm going to multiply my 15 on both sides, so I'm going to get sine of Z equals 15 sine of 24 over 7. And that's going to give me, I'm going to go ahead and use my inverse sine. So Z equals inverse sine 15 sine of 24 over 7. And in this case, I actually end up getting 60.6 degrees if I round to 3 significant figures. Okay, so I'm getting that this angle Z here is 60.6 degrees, right? And I can use that then to solve for the rest of the triangle. So I could find angle Y by summing my angles and subtracting from 180. And then I can also use law of cosines here, or once I have that Y, so if I take my 180, subtract off my two angles, I would get 95.4 degrees, so 95.4. I could then use law of sines to find my missing side here, which would look like sine of 24 over 7 equals sine of 95.4 over my missing side xz. Okay. In this case, that would end up being xz equals 7 sine of 95.4 divided by sine of 24. So xz would equal 17.1 rounded to 3 significant figures. So I should probably use an approximate symbol there. Okay, so that would be this particular triangle. The issue is I actually technically have another triangle that I need to test for. So I'm going to go ahead and erase this work. So if you need to pause to keep copying something down for that particular triangle, please feel free. I'm going to go ahead and erase everything that I got on here, though, to make some room for myself. Okay. So my other possible triangle that I can get, backing up a little bit to when I have this angle here. If I were to pretend like there's the hinge we mentioned earlier on our triangle at that point Y, and that side 7 here were to swing inward instead, okay, well, technically, since this is 7, I have a little blue isosceles triangle there where this angle on the left would also be considered 60.6 degrees. Which means if I take 180 and subtract 60.6 degrees, keeping in mind that if this were an IB exam question, you'd want to make sure to use the unrounded versions of these numbers, I could have an angle of 119.4 degrees inside the triangle right here. So I'm going to redraw this triangle just a little bigger, where I've got 7, 15, 24 degrees, and 119.4 for this obtuse angle. Okay. Now, I technically have a slightly different triangle that I could find x, y, and z here. So this is my other possible triangle, and this is where we get the ambiguous case where you might have two triangles that you have to solve for because we don't really know which one is actually happening here. Okay. Now if I go to solve, I would finish up. I would keep going with my law of sines. So I'm going to go ahead and try and find, or I can get angle y. I'm going to take 180 minus 119.4 minus 24. Okay, so 180 minus 119.4 minus 24 in my calculator. I'm going to get 36.6 degrees for angle y. And then I can do my law of sines again. So sine 24 over 7 equals sine 36.6. Again, being careful to make sure to use unrounded values throughout this problem over my missing side xz. So xz in this case would be 7 times sine of 36.6 divided by sine of 24, which would be approximately 10.3 rounded to 3 significant figures. If you were to do this with the unrounded answers, you'd probably get slightly different results than I did because I did use the rounded, but in the IB exam and things, you want to make sure not to use rounded answers for future parts of a question. Okay? But that's how we might get 2 triangles. Now that only ever happens in the ambiguous case when you have, again, the non-included angle between 2 sides, and the potential for 2 triangles only ever happens when the smaller side is across from the given angle. So in this particular case, our side, I'm going to do this in green, our side of 7 was across from my angle that was given, my angle of 24 degrees, and that side 7 was smaller than the side 15. Okay? The reason why that happens, only in that case, because if we come down to the triangle here on the left, okay, if I put my little hinge there, all right, because my angle that I'm given is 45, my hinge is going to be between the 2 given sides. That would make 41 the side that would swing. And if we just kind of reason through it a little logically, 41 is going to be too long to actually swing over, and 21's not long enough to give it room to swing to a different spot. So in this case, this would be only this one potential triangle because there's just not enough room for that 41 to swing to another spot. Okay? So in this case, in this triangle on the left, we would just do our law of sines and get one potential result for the triangle. Okay? Again, if you have any questions, I encourage you, please feel free to ask in class. If you aren't sure about, why there's 2 triangles and that sort of thing, I'm more than happy to answer. Otherwise, thanks for watching.